All right, so we're recording here. Let's just do our problems real quick. I'm going to copy and paste the data. And go ahead and relabel part. All right, I want to know, is this a significant correlation? So I go correlation matrix, put my two variables in there. Kendall's tau is a non-parametric, 95 CI. Plot the correlation matrix for fun. Look, see if it's linear. It is linear, the best I can tell. I don't see really any deviation from linearity here. So, is this a significant correlation? That's our first question. I'm going to move this over, get this nice and big for us. P-value is significant. Yes, it is. So that would be yes. Estimate the population correlation in words. So it's between 0.34 and 0.98. Now, a correlation of 0.1 is small, 0.3 is medium, and 0.5 is large. So this is between a medium and large correlation. Is the significance due to a violation of assumptions? No, because Kendall's tau p-value is also significant. So, no. Now, whenever there's a difference between the two p-values, you trust the non-parametric. Give me a headline for the result. Drink more coffee, be happy. It doesn't really matter. I just want you to see there. Like, you can be specific with it, right? Okay. Drink more coffee. Drinking more coffee is associated with more happiness. We know we can't say cause, that's all. But yeah, that's the headline. It doesn't matter for me. I just need you to realize what's going on here. Also, I want you, what I didn't do because I already did it, right? But look at this. This is saying, so this picture I don't like. So what I'm going to do is I'm going to reorder them. The data's all the same. But now what it did, once we get back over here, is it made happiness the DV and coffee's the IV. How do I know that? Just because it's a matrix, right? So coffee is my x-axis. This coffee goes with this axis. Happiness goes with this axis. So as coffee intake increases, so does happiness. In order to write this up, so n minus 2 is the degrees of freedom for a correlation. I wish it reported it. It doesn't. Let me see if, let me just double check. I'm going to put n in there just to be lazy. N is 7. 7 minus 2 is 5. So R with 5 degrees of freedom. Ranges from, has an R value of 0.87. So your 0.87 goes here. My lower and upper limits are going to go there. That's 0.34 and 0.98. And 0.98. And my p-value is, I'm going to report just the p-value right here for the Pearson's R correlation coefficient. So Pearson's R correlation coefficient, the p-value, 95% confidence interval. Kendall tau p-value n. Okay? And that is 0.011. You report p-values out forever. Now, there are rules. So when do you use a decimal, a zero before the decimal? When the score can be larger than 1. Correlations cannot be larger than 1. Neither can p-values. We are done with the problem.